Okay, we're going to start off today's lesson with a quick review. Scale factor is a concept we've been talking about, and that is a ratio between similar figures. And we've been talking about how when we're deciding our scale factor, that we always take the new figure over the old figure, or the new figure over the original figure. And that helps us determine the order of our ratio. Now, perimeter is a review term, and that is we typically talk about the distance around something. But what's important for us at this level is that this is a one-dimensional concept, and we always label it units. Area is the amount to cover something. Think about painting, think about wrapping paper, wallpaper, floor tile. That is a two-dimensional measurement. You take a length times a width, a height times a base. And when we label it, it becomes units squared. And volume is obviously the amount inside something. That is a three-dimensional measurement, and we always label it units cubed. Now that units squared, and units cubed is going to be important when we talk about our scale factor and our ratio of areas and our ratio of volumes, which we previewed at the end of yesterday. I'm going to do a little sidebar right now that's not on your guided notes, so find some blank space and follow along with these new notes. Just to be sure we understand this idea of scale factor and how it is impacted, why, like we talked at the end of yesterday, the 6-2 lesson, that area is k squared and volume is going to be k cubed. I'm going to show you an example here. If this is my original figure, and I'm going to call it length and width, and my new figure is here with a corresponding length and width, except I'm going to use a scale factor of 3. So k is going to be 3. That means that my dimensions are really 3L and 3W. So when I go to look at a length comparison, new compared to old, and you cancel your fractions, you can see it's 3/1. It is my scale factor. That would work the same if I did perimeter. The perimeter of my new figure is 3L plus 3W plus 3L plus 3W over my perimeter of my old one, L plus W plus L plus W. That simplifies into 6L plus 6W over 2L plus 2W. Now if I do a little bit of algebra on the top and I factor out a 3, I'm going to have 3 times the quantity 2L plus 2W all over 2L plus 2W. And what we see can happen is these cancel. And again, my ratio of perimeters is 3/1, which is K. Now what happens when I get to area? Now the area of my new figure is 3L times 3W over my old figure, which is just 3W. So I have 9LW over LW, which is going to cancel and leave me 9/1. Now how is 3/1 related to 9/1? It's k squared. I squared 3 to get to the area comparison. Because area is a two-dimensional measurement, my scale factor is squared. In looking at a volume problem, if my old figure here has a height and a width and a length, and I'm going to use a scale factor of 3 again, then I have a 3 high and a 3W and a 3 long. When I go to look at the volume, Volume of a box is length times width times height. My volume of my new is 3h times 3w times 3l. My volume of my old is hwl. Combine like terms in the top. 3 times 3 times 3 is 27 lwh. My denominator is lwh. You can see those variables are going to cancel, and I'm left with 27 over 1. Now, it may not be obvious to you, except if you look up here, that 27 is really 3 cubed over 1. So this is k cubed. If I'm increasing all of my dimensions by a certain amount, that is going to dramatically impact by a factor of k squared and k cubed for area and volume respectively. The other thing we need to review are some exponent rules because they come into play. If you have a fraction raised to a power, the power gets distributed. So I have a to the n over b to the n. So if I look at an example and I have something like x over 5 cubed, that becomes x cubed over 5 cubed, which is x cubed over 125. Another exponent rule is if I have a quantity raised to a power. That power gets distributed, in a sense, across the quantity. So I'd have a to the nth, b to the nth. And this is a high mistake area for students. So for example, if I have 3n, the quantity cubed, literally that means 3n times 3n times 3n. You don't want to write all that out. So really we're talking about 3 cubed n cubed, which is 27 n cubed. Another exponent rule we have to look at is the square root of a fraction. You may not be able to simplify that fraction, so one of the easiest things is you can split that square root and take the square root of the numerator over the square root of the denominator. So as an example, if I have the square root of 9 over x squared, I can take the square root of 9 over the square root of x squared and get 3 over x. The last point about exponents that I want to make is that x cubed and the cube root of x are opposite operations. If I give you k cubed and you want to know what k is, you have to take the cube root of that. There are buttons for this on your calculator. If you don't know how to work your calculator, come see me. The buttons you're looking for are going to be buttons that look like this, and then up above it as a second function, you're going to see that, or you're going to actually see a button that looks like that, and it'll vary a little bit from calculator to calculator. Now, to go back to the lesson. If I'm given that ABC is similar to DEF, let's go ahead for consistency and identify this one as our new and this one as our old. The scale factor, which is k, is going to be 6 over 3 or 10 over 5. Both of those are 1/2. Now the perimeter of ABC and the perimeter of DEF, initially I don't have enough information to do that, so I need to use the Pythagorean theorem to find those hypotenuse. And so I have 6 squared plus 10 squared is equal to c squared. And I'm not going to show all the work, I'm just going to have you trust me that if you do it, you'll end up with 11.7. In triangle EDF, I have 3 squared plus 5 squared equal to c squared. When you work that one out, you'll find out that c is 5.8. Now using those two values, you can easily calculate the perimeter by adding up all three sides. And when you do that, you'll find out that the perimeter of triangle ABC is 27.7, the perimeter of triangle DEF is 13.8. When I put these into a ratio, I expect to get, I made a mistake up here, I'm sorry, 2 over 1. Bet you were all wondering about that. When I put these two into a ratio of new over old, if I do this division, I get this. Now I should get 2. This isn't quite 2, but remember you introduced rounding error when you did that Pythagorean theorem. It's close enough. Okay, if you got 2.5, I'd be concerned. If you have 1.998, you're good to go. But remember that rounding error. Now, what is the area of ABC and the area of DEF? Now, area is going to relate by a factor of k squared, so I expect this value to be 4. Okay, I'm looking for it to be 4, but they should compare at k squared. Remember, area of a triangle is 1/2 base times height. So when I do this, the area of triangle ABC is going to end up being 30, and the area of triangle DEF is 7.5. So my ratio of their areas is 30 to 7.5, and when you do that division, you get 4, which is k squared. Now the next example is a circle. Scale factor, again, let's identify this as our new and this is our old. So my scale factor here, just k, is 5 over 2 radii to radii, which is a one-dimensional measurement. Remember, circumference of a circle is pi times diameter, or pi times 2r. I expect, circumference is like perimeter, I expect them to compare at a value of k, but let's see if they do. The circumference of A is going to be 10 pi, leave them as exact answers. The circumference of B is 4 pi. When I put those into a ratio, 10 pi over 4 pi, the pi's cancel. 10 and 4 share a common factor of 2, and the circumference, as it should, compares with a factor of 5 to 2. Now the area, and if you remember, area of a circle is pi r squared. Remember, I expect this to be k squared. The area should compare at a factor of k squared. So let's see if they do. The area of circle A is going to be 25 pi. Again, leave it exact. The area of circle B is 4 pi. Put those into a ratio, 25 pi over 4 pi. The pi's cancel. They compare at a ratio of 25 over 4, which is indeed 5 squared over 2 squared. And so my formulas are all working out